have a square of area 100 square units. What is the side length of this square? Well, it is very easy to answer. The side length is 10 because we know that 10 times 10 equals 100. We can also say that 10 squared equals 100. Since 10 squared equals 100, it means square root of 100 is 10. The root of the square is a number. When we imagine this, if we have this square and the area of this square is something, so the side length will be the root of this number, like root of this squared numbers. So we are going to use this method to generalize a method to find the square root of any number. So let's start the video. Here we have another square with area of 225. Can you find the side length of this square? Well, you can find, but we can try to understand the method so that we can apply to large numbers. Suppose we don't know what is the side length of this square, so we are breaking this large square into squares that we can easily find squares of. Initially, I know that I can put the square of 100 here because I know that the side length will be 10, right? It is easy to answer, right? So but there is still some length which is missing to find. So what we will do, we know that the area of this purple region, or you can say this composite figure, is 125 because the total area was 225 and we have covered the 100 squares, so the remaining area is 125, right? So now we need to find what should be this side length if the area of this purple square is 125. Well, since it's a composite figure, it's difficult. So what I am doing, I am imagining a square here. Why I am saying this is a square? Because these two side lengths are equal. So here we have another square, right? So now we have two rectangles and a square. We know that the sum of the areas of these three figures is 125. Let's do one more thing. We know that some of the other sides also, because if this side is 10, so this side of purple rectangle should be 10, and so this side and these sides, and we know that all of these sides are just the same but they are unknown, right? So since what I'm doing, it is difficult to, now we are going to imagine a number that we put here and that satisfied this relationship. Like for example, if I have to put a number 1 here, so I have to put 1 here, I have to put the same one here and the same one here. Then I have to find the area of this rectangle, then this square, and then this rectangle, and then I have to add to check whether it is equals to 125 or not. So just to reduce the number of steps for doing this, I am just decomposing and rearranging this. Okay, let's do it together. Okay, suppose if I cut this or decompose this rectangle and paste it here like this. Okay, it is easier to imagine because now I have the rectangle with the same area of 125 because I did not change the region. I just decomposed and rearranged. But now I have a rectangle and the one side of rectangle is simply 10 plus 10 because we had 10 and 10. So we can add them, so we get 20. So we know that I just need to imagine a number for two places, and we can satisfy whether the number I have taken satisfy this relationship. For example, if I place 1 here, so it will become 20 plus 1, and the other side is also 1. So the area, if this is the side, so it will be 21 because 21 plus 21 multiplied by 1 is 21. So it is not satisfying this relationship. So next I have 5 here. So the one side of this rectangle is 20 plus 5 and the other side is 5. So if we are finding the area of this rectangle, it should be 25 times 5, which is 125. It means it satisfies the relationship. It means this number should be 5. So we have found the missing side length, which is 5. So we know that this side length is 10 and this remaining side length is 5. So the total length is 15. So the square root of 225 is 15. So this is the process where we can visualize to find the area square root of any numbers. Now let's do it without diagrams and record the steps differently so that we can do it with large numbers. We are taking the same number 225 and using this notation like this, which is similar to division 1, because we are going to follow a similar process. Right, for example, what we did first, we simply take out the square that we can easily find. Like for example, 10 times 10, it is 100. So we can know the square of the side length is 10 and the square is 100. So we are taking away 100 from 225. Right, so we are left with 125 as we left in the figure. What did we do next? Like see what we did next. I'm going backwards just to show what we did first. We simply cut and paste here, and then what happened, the two sides here, we simply double the side length of this square. This is 10 and this is 10 from this rectangle, so it becomes 20 like this. Right, so we are following the same step in our division. After subtracting this, we are adding this 10 to another 10. You can imagine why we are doing this. So we get 20. So now we are going to add a number to this 20 and multiply it with the same thing. So we get 125. So what if I take 1? So 21 times 1 is 21, so which is not satisfying this relation. So we can take a larger number. So what if I take 5? So 25 times 5 is simply equals 125. So here I have got my answer. The square root of 225 is simply 15. Right? It is simpler one, but here I'm going to show you the even simpler version of recording the steps of finding square roots. Okay, let's do it together. Again, we are taking the same number 225. Okay, and using the same notation, but this time instead of using the whole numbers, writing the full numbers, we are just using the place value concept and taking the non-zero digits. For example, instead of taking 10, I'm writing 1 times 1, which is 1. Actually, this one represents 10, this one also represents 10, and this one represents 100. I am not mentioning the 0. I will simply subtract it from the 100 place, from 200, right? So we get 100 here. I am writing 1 here, but it is on the hundreds place, so it is representing 100. Now I am taking the remaining 25, so now I have got 125 here. Next, I will add this 1 because it was 1, so I am adding 1. Basically, it was 10 and I am adding another 10 to this, and I have got 20, and I have recorded only 2. Now we need to take a number with 2 because it is 20, so next digit can be written with it because we are using the place value concept. It is tens place and it is ones place. So basically this is 21 times 20, 21 times 1 is 21. It is not satisfying, so we are taking 5. 25 times 5 equals 125. So this is a simple method that we can simply follow. Let me repeat the steps here. Simply we take the first digit here, which is 2. So we are taking to look for the square that we can easily find, like 1 times 1 is 1. We cannot take 2 times 2 because it will become 400, that we cannot take away from here. So I have taken the 10 times 10, or 1 times 1, 1, and the remaining has mentioned here. Now I take the next group, it becomes 125. I add this number to this number, I've got another number which is 2. I'm going to put a digit here and I'll multiply the same thing with the same number, same digit. 21 times 1 is 21, not satisfying. I'll take the another number. If 25 times 5 satisfied, so it means our answer is simply 15, that is here. So I hope this is known as the division method of a square. If you have understood, please try this method on some numbers and please mention your experience in the comments below. Thank you so much.